In this video, we're going to take a look at a playlist I put together on a very popular topic these days, which is data mining and machine learning with Python. Now, data mining is becoming very popular now because, number one, there's a lot of data to mine, and number two, there are a lot of insights that we can gather from that data. And from those insights, we can be more wise about how we spend our limited resources and where we allocate them. So, in a nutshell, take a look at this. We'll typically have a series of features, and they will be used to pick a target. The target is typically a Y. The features are typically X1, X2, X3. If we're trying to predict ones and zeros here, let's see, is X4 a good predictor? Well, probably not, because the 0 is attached to 98. If this 99 weren't here with a 1, then maybe we could make a case, but 98 is between 40 and 99, and we really can't predict much on that. X3, is that a good predictor of 1 or 0 for Y? Probably not, because 1 and 0 both have a value of 12,000. Now X2, note all those values are the same. What about X1? Well, you notice the only Y that is 0 is Dayton. And so we can start to put together a model here that if we're in the city of Dayton, it's going to be 0, whatever that means. If we're in Cincinnati or Cleveland, it's going to be a 1. And that's effectively what we're looking at with machine learning. Now, you might say, well, wait a minute. How do you know? What if there were another row that had Dayton and a Y of 1? That's entirely possible. And that's one consideration that we need to think about, which is in order to mine data, we typically need to have a substantial data set to mine so that we can actually see these patterns. To start, we want to take a look at some Python essentials. Python is a very much growing language right now. It's been a clear number one in the TIOBE index lately, and a lot of it is the popularity of data mining, and a lot of that is we have a lot of data to mine. If you look at the amount of data that's generated every second right now, it's much, much more than we've had at any other time in our history. Review data, GPS data, things like this. And so it gives us a lot of data to mine. And Python, and especially the libraries written in C, are very efficient at mining the data. So we're going to take a look at NumPy, Pandas, Scikit. We're going to take a look at collections like arrays and data frame. And we're going to take a look at slicing, or taking a large, say, two-dimensional, for example, set of data and being able to chop it up based on either rows or columns or filters or lambdas or several other things that we can do. Plotting and graphing is an important consideration when we're looking at data mining, because a lot of times we're dealing with a big amount of data, and we want to look for things like outliers. And when we look at outliers, we might say, okay, well, I want to remove these because they're anomalies. But another thing we might want to do is say, I want to consider these as a separate group. Here's one of my favorite examples, and I love using real data. This is a look at streetcar ridership in the city of Cincinnati. The streetcar loop serves the downtown and over the Rhine neighborhoods in about a 3.6-mile loop. Not far from my apartment, about 4 blocks, something I use with some frequency. And if you take a look at streetcar ridership, you see this thing and you think, oh my gosh, that's an outlier. Then you see these other things and you say, well, they're outliers too. Well, this is from the year 2022, and in the year 2022, as we have in hopefully even years, every other year in Cincinnati, there's a large art installation, I guess that's what you call it, where they show lights on the buildings downtown and kind of like an animation, and it's called Blink, and it's enormously popular. And it just happens to follow the streetcar route. And so what you tend to have there are a lot of people who have never been to Cincinnati before or have not been downtown often and are using the streetcar. Just like right before that, the fireworks, the Labor Day fireworks, which are also a big downtown event, Taste of Cincinnati, and opening day, and the other things that tend to draw a large crowd. But then you see this other kind of just normal ridership down here, which is mostly things like downtown office workers and residents. So this is an ideal case where you see that we don't necessarily want to eliminate the outliers. It's just a different group. And so we want to separate the outliers, and we want to model them separately from the other the numbers that kind of fall in a more normal range, which tend to be more regular writers of the streetcar versus just one-off writers. So there's several other plots we're going to look at. That's just an example, but several other plots, and the whole idea here is how we can look at our data and prepare it for our supervised and unsupervised learning. Now, supervised learning is really neat, and this is what really got me excited about data mining back when I was in grad school many, many years ago. It was a real eye-opener. This idea that you can use data to make some predictions. You can use data to figure things out. One of the first ways that I used regression was when I worked for a credit card processing company, and we were trying to figure out what our peak day, our peak hour, peak minute was going to be during the year, because this is back in the mainframe era. This is back when scalability wasn't as easy as going to the cloud and say auto scale. You had to plan these things out. And so I was able to put in some factors like how close to Christmas, what's the day of the week, other things like that, and say, okay, what will be the busiest day? And came up with a pretty darn good prediction. Other predictions are things that kind of sound obvious when you look in hindsight, but you say, okay, I apply nitrogen, phosphorus, and potassium to crops, and what's the response? Well, too little, crops won't grow enough. Too much can be toxic, because fertilizers are a salt and they can desiccate or effectively pull water out of the plant. But then there's that zone that's just enough. But then we also realize that NPK, the three major nutrients, will affect different parts of a plant. How it flowers, how it fruits, and its vegetative growth. So in the limited resources that exist in the soil, do we want those to go into growth of, say, a stalk, or do we want them to go into growth of a fruit? And we can take a look doing a regression analysis to figure that out. Now, there are two types of regression we're going to take a look at. One is linear regression, where we're trying to predict a continuous number. That could be something like yield of a set of crops. And there's also logistic regression, where we're trying to just bucket things into categories, or say, which could be things like likely to purchase a large home, likely to purchase a rural home, likely to rent in the city, likely to rent in the suburbs, something like that. So we can basically take a set of data and say, which one of these are you most likely to fall into? And then maybe if I'm a landlord, that will help me narrow down my marketing. If I'm a realtor, that might... And then if I'm a landlord, I can say, okay, well, that's where I might do my marketing. On the other hand, if I'm a real estate agent, well, okay, here's the group that I'm going to market to. Unsupervised learning is fun and easy to do, and it works well with large data sets. So we can use things like k-nearest neighbors, where we throw things up on a graph, and then any new items that we add, we say, okay, what are your nearest neighbors and what are their attributes? And then we can effectively assign those attributes to this new item that we've added to the graph. We can also do some k-means analysis, which is a lot of fun. And that's where we're saying, okay, here's a list of features, and let's put these things into groups. And then let's look at the distance between groups and the distance within a group. In other words, between each of the group members and its centroid. And the trick is finding out how many of these groups or clusters that we want to create. But it's interesting to find the data that's uncovered here. I did a few different examples here. One was looking at the politics of counties in the state of Oregon. Reason why I chose Oregon is it's a very binary state. If you look at the counties that are along the coast, Portland, Salem, that area, they tend to be very different from the counties that are closer to Idaho. So different, in fact, that those counties closer to Idaho are looking to essentially secede and join Idaho now. So it's an interesting, okay, are you this or are you that? There's not a whole lot of in-between in Oregon. You're either one or the other. Now, for k-means, I took a look at Ohio counties, and this was really neat because we can take a look at each of the individual variables that we're analyzing and look at the value for each county and the differences for each county. So for total population, you see Cuyahoga County is very dark, which is not a surprise because that's where Cleveland is. If we take a look at less than high school percent, Adams County is very dark, which means it has a high value. And then we take a look at age 65 and older percent, and Athens County is very light there, meaning it's low. Why is that? Well, that's where Ohio University is located. Otherwise, it's a very rural county. And so it's a bit of an outlier. But it's neat as we choose the number of groups that we have, we can see how different counties that have certain values in common end up getting grouped together. And in this instance, there was one outlier called Holmes County for a very interesting reason. But I'll save that surprise for when we actually get to that k-means analysis. Once we've explored the concept of supervised and unsupervised learning, we'll move on to a topic that is growing very quickly these days, which is text processing. So when we're looking at text, we could be looking at things like our reviews on a public store. Or if we have a product that is going to be available at some time in the future, we can get an idea of demand by looking at the comments that people are placing on public forums. Is this product going to be a hit? Did we make enough of it? Or is it going to be a flop and we made too much of it and we need to stop making more of it? That's what we can take a look at when we're doing text processing. We're going to explore something called TF-IDF, which looks at the frequency of terms within a document and the frequency of terms across multiple documents. I put together an example here that's a fairly practical one that we'll get into, of course, in one of our videos. But effectively what I did is I went out to LinkedIn and I grabbed the description from jobs that were recommended for me, and then I also took my own LinkedIn overview from my LinkedIn profile, and I matched these together to say, okay, where do I have a unique skill for a unique job? We can take a look at these word frequencies and see where I might have something unique. So, software developer, we might see that in many job descriptions. Engineering manager, maybe we'd see that in fewer job descriptions. Mobile developer with point of sale experience, things like that. When we get more specific, we're going to find a more unique match. And this is something that we really see happening a lot these days, where a lot of times you can have a job posting and several hundred people apply. And so there's an automated way to say, okay, of these 100, these are maybe the top 20 candidates, and then we can filter that down into the candidates who we're going to interview. So I hope you enjoy this exploration of data mining, machine learning, business intelligence. It's definitely a very growing field and a field with a lot of potential, where we get that ability to look at data and have the data tell us things, have the data predict things for us. So I look forward to reading your comments. Thank you.